Hello students. Now we are going to see the algorithm for SHA. SHA means Secure Hashing Algorithm. It is one of the cryptographic hash functioning algorithm. This algorithm was developed by National Institute of Standards and Technology along with NSA. In the year of 1993, SHA was published as a Federal Information Processing Standard. In the year of 1995, it was just revised and the name was changed to SHA-1. It is a modified version of MD5. That is, it's very similar to MD5 algorithm. MD5 algorithm means message digesting algorithm. Now, let's see what are the inputs and outputs and functionality of this algorithm. The input message length is less than 2 power 64 bits. The output of SHA, that is message digest, is 160 bits in length. SHA is designed to be computationally infeasible to obtain the original message given its message digest. Find two messages producing the same message digest. Now let's see how SHA-1 algorithm works. The first step is padding of bits. This step is very similar to the first step of MD5 algorithm. The aim of this step is to make the length of the original message equal to a value which is 64 bits less than an exact multiple of 512. So, to understand the padding of bits, we have considered one example. In our example, let's assume that the length of the message is 1000 bits. Now we have to calculate the length of padding bits. So to calculate the length of padding bits, the length of the original message plus the length of the padding bits plus 64 bits. Now we get one total value. This value should be in the multiple of 512. So, in our example, the length of the padding bits should be in 472. So, while we add 64 bits in the length of the message plus padding bits, these 64 bits actually, this is the length of the message. It will explain in the next step. So, the next step is append the length of the message. After padding bits are added, the next step is to calculate the original length of the message and add it to the end of the message after padding. The next step is divide the input into 512 bit blocks. Now we divide the input message into blocks each of length as 512 bits. The next step is initialize the chaining variables. Actually, in the MD5 algorithms, we have only the 4 chaining variables A, B, C, D. In these algorithms, we have additional one variable, that is E. These variables and the initialization values are shown in this table. The next step, the process or begins, the actual algorithm that begins. So the next one is the copy the chaining variables A to E into the variables A, B, C, D, E. That is A, B, C, D, E is the abstracted view of the separate variable A, B, C, D and E. So the next step is the divide the current 512 bit block into 16 subblocks of 32 bits. In our algorithm, it has 4 rounds. Each consists of 20 steps. So it makes only the 80 iterations in this algorithm. We have only 3 inputs for each round. The first one is the input message, that is 512 bit block. It's already divided into 32 bit blocks. So we get 16 sub blocks from the 512 bit blocks. The second one is the register variables. We have already seen, that is ABCDE. It is an abstracted view of ABCDE. And the third one is the constant, which is K of T. T ranges from 0 to 71. These K of T values are shown in the next table. These are the K of T values. So in MD5 algorithms, we have only 64 constants, but in SHA algorithms, we have only the 4 constants are available. So each constant for each round. The first one is first constant for first round, second for second round, third for third round, and fourth constant for fourth round respectively. So already we have shown SHA has total of 80 iterations, that is 4 rounds and 20 iterations. So to make it as 80 iterations. So in mathematically the operation, it consists of the mathematical operations. ABCDE is equal to E plus process P plus S power 5. The equation is shown in your PowerPoint slide. But ABCDE, it's a register. It's made up of 5 variables A, B, C, D and E. Process P, it is a logical operation. It will shown in the next forthcoming slides. S power T, it's a circular left shift of 32 bits subblocked by T bits. W of T is a 32-bit derived from the current 32-bit subblock. So W of T values are shown in the next forthcoming slides. K of T is one of the 5 additive constants. So already we saw in process P. So process P in each round, it varies from each round. So it's shown in the table. This is the diagrammatic representation of the mathematical operation of SHA1 algorithms. It's already shown. So we already saw the WT value in this algorithm. So how to calculate the W of T value for the first 16 words of W, that is T ranges from 0 to 15. The same M of T value, that is message digest value, is stored in the W of T value, and the remaining values of W of T, that is 16 to and up to 79, the W are derived using the following equations. The equation is shown in the slide. This is the end of the algorithm. Now let's see the comparison of MD5 and SHA1 algorithm. So the points of discussion is the message digest length. In MD5 algorithm, it's only is 128 bits. In SHA1 algorithm, message digest length is 160 bits. So the next one is attack to try and find the original message given a message digest. That is the first functionality. In MD5 algorithm, it requires 2 power 128 operations to break in. To break the first functionality in SHA1 algorithm, it requires 2 power 160 operations to break in. So the next functionality, it requires 2 power 64 operations to break in. That is half of 128. In SHA, it requires 2 power 80 operations to break in. And compared to the speed, MD5 is faster and SHA1 is slower. And successful attempts so far in MD5, there have been reported attempts to some extent. SHA1 algorithm, no such claims so far. The software implementation is very similar and simple in both the MD5 and SHA1 algorithm. In this slide, we see the parameters for various versions of SHA1 algorithms. And we have already saw the SHA1 algorithms along with the other algorithms of SHA, SHA256, SHA384, SHA512. Thank you, girls. If you have any doubts, you can clarify through mail. Thank you.